In question 10, the function f is defined by f of x equals to x squared plus k upon x plus 2 for x greater than 0. In part A, it says given that the curve with equation y equals to f of x has a stationary point when x equals to 2, we have to find k. Now, for the stationary point, we know that the derivative or f dash of x will be equals to 0. So in the first step, we can first write the expression as x squared plus k x to the power minus 1 plus 2. Now, when x is 2, the dy dx will be 0. So first finding the expression for the derivative, that will become 2x. Minus 1 will multiply by k, and the power will decrease by 1. And the derivative of 2 will be 0. So we can write the expression for f dash of x as 2x minus k upon x squared. Now substituting 0 in place of f dash of x and x equals to 2, this will become 4 minus k upon 4. So we can write it as k upon 4 will be equals to 4. So the value of k will be equals to 4 into 4, which is 16. In part B, it is saying determine the nature of the stationary point. So for the stationary point, we'll have to find f double derivative of x. Now to find this expression, the expression for f dash of x was equals to 2x minus k upon x squared. So this will be 2x minus, we can write it as 16 upon x squared. Writing it as 2x minus 16x to the power minus 2. And then differentiating this, we'll get, so the derivative of 2x will be 2, minus 2 into 6, minus 16 will be a plus 32, x to the power minus 3. So we can write it as 2 plus 32 upon x cube. Now the value of x was 2, so substituting 2 in place of x, we'll get 32 upon 2 cube, which will be equals to 2 plus 32 upon 8. 32 upon 8 is 4, so this will be 6. As f dash of x in this case is greater than 0, we will say that it will be a minimum point. In part C, it is saying given that this is the only stationary point of the curve, find the range of f. Now, from the expression, we know that the minimum point was at x equals to 2, and f of x was x squared plus k upon x, so that will be 16 upon x plus 2. Now the minimum point was at x equals to 2, so to find the range of f, as it is a quadratic function and it has a minimum point, so we have this x value, and for the range we have to find the y value. So substituting x equals to 2, this will become 2 squared plus 16 upon 2 plus 2. So this will become 4 plus 8 plus 2. So f of 2 at the minimum point will be equals to 8 plus 4, 12 plus 2, 14. Now, as this is a minimum point, all the values of the function will be above this point. So we'll say that f of x will be greater than or equals to 14.